Now children, will be solving next problem, problem number 2, and this is also a problem based on simple harmonic motion with the equation, displacement equation in terms of initial phase or epoch. You have learned on the last video also and in the last class. Okay, and problem number 2 said that the time symbolized by small t and displacement symbolized by small y, relation of a particle executing simple harmonic motion is given by the equation, and that equation is y equals to 0.50 sine 500 t plus 0.5. So let me start the solution of this question, and I write down the equation which is given is y equals to 0.50 sine 500 t plus 0.5. Now I give this as equation 1. Now this is actually the displacement equation in simple harmonic motion, where your displacement, we measure the distance in centimeter and time we measure in what? Second. Now from here what we need to calculate? Calculate the value of amplitude, angle of frequency and the initial phase of the particle. So in order to calculate the value, so this equation, now we can compare with what? The general equation of simple harmonic motion. So write down, since the general equation, let me write down the general equation of what? Motion, simple harmonic motion, is given by y equals to a sine omega t plus phi. Yes, children, we have done this part already in the last class. Okay, the displacement equation in simple harmonic motion can be expressed even in terms of this phi called initial phase or epoch. So this is equation number 2. Now we can compare these two equations and calculate the value. Children, if you compare equation 1 and 2 both sides, we can calculate the value, and the first value that we calculate is the amplitude, because in the relation equation number 2, a means the amplitude. So this y and y, so a is equivalent to 0.50. So if you see, the amplitude is how much? 0.50. Therefore the amplitude of this particle is how much? I write down the amplitude, the first part answer. The amplitude A of a particle is 0.50 centimeter, because we compare equation 1 and 2, and from that equation A is equivalent to 0.50 centimeter. Now after calculating the amplitude, we have to find the angle of frequency. We have to find the what? Angle of frequency. Okay, but before we calculate the angle of frequency, okay, if you see the relation, if you compare from equation 1 and 2, if you see, sine and sine is same, t and t same. Now this 500 is equals to omega. Now, and you know omega is the symbol of angular frequency. So you can see, just compare this two equation. Your omega, which is angular frequency, is equals to 500, and the unit is radian per second. Therefore the angle of frequency, so we have calculated the angle of frequency. The angle of frequency, and the symbol is what? Omega is also 500, and the unit is radian per second. Angular frequency unit is radian per second. Now once you know the angular frequency, we can even calculate the frequency of the particle. Now basically frequency of the particle is marked by nu. Nu be the what? The symbol we use for frequency of the particle. The frequency of the what? Particle. Sometimes we can write the symbol of frequency as f also, small letter f, or n also we can use. Okay, so this time we use nu as the symbol of angular frequency. And you know what is the relation? Angular frequency, that is omega equals to 2 pi nu, the frequency of the particle, which means nu equals to omega by 2 pi. So let me substitute value. Omega means 500 by 2 pi. Okay, now we can cancel 2 1 2, 225. 250 are 500. So we can leave the answer this way also. 250 by pi. Yes, you can leave the answer this way also. And the unit is what? Hertz. We can write hertz, or we can also write per second. So what is the frequency of the particle? 250 by pi hertz or per second. Okay, so this is the frequency of the particle. This is the frequency. This is the frequency of a particle. Now after calculating the frequency, the question says that to calculate the initial phase. Initial phase is also called epoch. Now this can be also calculated by the relation. And children, if you look at this equation 1 and 2, this phi is called initial phase or epoch, and that is equals to 0.5. because if you compare plus and plus, so 0.5 is equals to phi, and that is called epoch. Therefore, the initial phase of particle, which is marked by letter phi, is 0.5, and the unit we simply write as radian. We mark by unit radian. So the initial phase of the particle is 0.5 radian. So this is the solution of problem number what? 2. Okay. Now we'll be solving next problem, that is problem number 3. Now problem number 3 says that the acceleration of a particle executing simple harmonic motion is pi square by 2 centimeter per second square. Now this is the acceleration of particle, okay, when the displacement is 2 centimeter. Now your displacement is also in centimeter CGS unit, and acceleration is also given in CGS unit. So from here what we need to calculate? Calculate is time period. Now you need to calculate the acceleration particle, time period of particle when the acceleration and displacement are known. So we use the formula of acceleration particle at any instant of time. And let me do the solution of this question. So as for simple harmonic motion, okay, I write down in simple harmonic motion, SHM, the acceleration, okay, the acceleration of a particle, okay, at any instant of time, at any what? Instant of time, okay, from the what position? This is actually from the what position? From the mean position. This is from the mean position. Is given by the relation, and the relation is alpha equals to minus omega square y. Yes. Now y means the displacement. Out here where y is the what? Displacement. See this relation, we have done it already. And you know what is omega? This is what? Angular what? Velocity or angular frequency. And this is basically what? Remain constant. Now from this relation, if you see, your acceleration is given how much? Pi square by 2, okay, centimeter per second square. And your displacement is given how much? 2 centimeter. Okay. Now from this acceleration and displacement, we calculate the angular frequency. But when we calculate the value of angular frequency, we neglect minus sign. And you know why we neglect? Because minus sign in the expression acceleration actually indicate the direction of acceleration. Okay. So I write just I don't neglecting minus sign. Neglecting what sign? Negative sign. So let me just write down the relation as alpha equals to omega square y. If alpha equals to omega square y, then omega square equals to alpha by what? Y. Okay. Now let's substitute the value and calculate. Now alpha means how much? Pi square by 2 by y means what? 2. So this is simply pi square by 4. Because this 2 and 2 reciprocal means it will be multiplied. So omega square is pi square by 4, and the unit is what? Radian per second. But actually we need to find what? Omega. So omega will be equals to square root of pi square by 4. Okay. So square root of pi square. Square root of pi square means pi, and the square root of 4 means what? 2. So your value of angular frequency, which is coming as pi by 2, and the unit is radian per what? Second. This is angular frequency. But actually we need to find what? Time period. Therefore, your time period formula is what? 2 pi by omega. So let me just substitute the value. 2 pi by, your omega means what? Pi by what? 2. And this pi and pi cancel out. 2 into 2 by 1. Because this 2 will reciprocal and multiply. So 2 2s are what? 4, and it is second. So the unit is what? Second. So what is the time period of the particles? 4 seconds. So the final answer of time period as we have calculated is what? 4 seconds. So children, I solved problem number 3 also. Now there are other numericals to solve also, and we do in the next YouTube video.